In today's video, we're going to take a look at hydrocarbons, and specifically at alkanes. First though, it's worth understanding that this whole area of chemistry is known as organic chemistry, which just means that it's all about compounds that contain carbon. You'll see over and over again in chemistry that carbon is a really useful element for making large compounds, because each atom of carbon can form 4 strong bonds, with the most common atoms to be bonded to being either other carbon atoms or hydrogen atoms. Now, lots of molecules only contain these 2 elements, and collectively we refer to all of these molecules as hydrocarbons, which we can define as any compound that's formed from carbon and hydrogen only. So this molecule, which is called butane, is a hydrocarbon, but this similar molecule, called butanol, isn't a hydrocarbon, because it also has an oxygen atom. The most simple type of hydrocarbons are a group called alkanes, and you need to know the first 4 in the series. The smallest is methane, which contains just a single carbon atom bonded to 4 hydrogens, because remember, carbons always have 4 bonds. Then we have ethane with 2 carbons and 6 hydrogens, propane, which is C3H8, and butane, which is C4H10. Now, if you look at all of these compounds, you'll see that they grow by 1 carbon and 2 hydrogens each time, but otherwise they're pretty much the same. We call groups of organic compounds like this homologous series, and it means that they all have similar properties, and so react in a similar way. It also means that we can write a general formula, which describes the entire series, and in the case of alkanes, the general formula is CnH2n plus 2. This might look a bit complicated, but all it means is that if the compound contains n carbon atoms, then it will contain 2 times n plus 2 more atoms of hydrogen. So if we had an alkane with 3 carbon atoms, like propane, then n would be 3. So it would have to have 2 times 3 plus 2 hydrogen atoms, so 8 hydrogens, which would give it the formula C3H8. Now, you only need to remember these first 4, but you could be asked to use this general formula to work out the molecular formula of much larger ones. For example, octane is an alkane with 8 carbon atoms. What is its molecular formula? Well, we know that for octane, n will be 8, because that's how many carbons it has. So it must have 2 times 8 plus 2 hydrogens, which gives us 16 plus 2, or 18. So its molecular formula would be C8H18. Before we finish, we just need to mention that one of the key features of alkanes is that they're saturated compounds, which means that every carbon atom has 4 single covalent bonds. There aren't any double bonds. For example, if we were to take this molecule of propane and change one of these single bonds to a double bond, then each of the carbons involved would have to lose a hydrogen, and what would have left would no longer be an alkane. Instead, we would class it as an alkene, which we'll see when we take a look at cracking hydrocarbons in a later video. In our next video though, we'll stick with alkanes by taking a look at their properties and seeing how to write equations for their combustion.
I've never seen a diamond in the flesh.
We saw in the last video that alkanes are a homologous series of hydrocarbons that contain only carbons and hydrogen atoms, with no double bonds, and we covered the names of the first 4 alkanes in the series. In this video though, we're going to talk about the properties of alkanes, and then see how we can write equations for their combustion. Although all alkanes have similar properties, there are trends that you need to know about as the length of the carbon chain increases. The first is that the boiling point increases with chain length. So these 4 here all have fairly low boiling points, and so exist as gases at room temperature, because they have the shortest chains. However, longer alkanes, with more than 4 carbons, are liquids at room temperature. And if the chains are really long, then they could be solid. This feature actually explains their next property as well, which is that shorter alkanes are more volatile, meaning that they evaporate more easily, because of that low boiling point we just talked about. Meanwhile, longer alkanes are more viscous, which just means that they're kind of thick and sticky, like honey. The last property you need to know is that shorter alkanes are also more flammable, which means that they're easier to ignite or burn, as we'll see when we come to crude oil. The next thing we need to look at is combustion reactions. One of the main uses of hydrocarbons, like alkanes, is for fuel, because they release loads of energy when they're burned with oxygen. As long as there's enough oxygen available, we get complete combustion, which is when a hydrocarbon reacts with oxygen to form carbon dioxide and water, releasing loads of energy in the process. So we could say that it's an exothermic reaction. We could also say that the hydrogen and carbon in the hydrocarbon are being oxidized, as each of the elements is combining with oxygen to form CO2 and H2O respectively. Now, when it comes to exams, you need to be able to write out the equations and balance them. For example, you could be asked to write the balanced equation for the complete combustion of propane. We saw earlier that propane is C3H8, so we'll react this with O2 to form CO2 and H2O. Then all we need to do is balance it. We know that on the left we have 3 carbons, so on the right we'll need 3 CO2s. We also have 8 hydrogens on the left, so because each H2O molecule contains 2 hydrogens, we know we'll need 4 of them on the right. Then lastly, we need to balance the oxygens. On the right, we now have 6 oxygens in the CO2s, plus 4 oxygens from the waters, so 10 in total. So to get 10 on the left, we'll need 5 oxygen molecules. And finally, we just need to double check that all the numbers balance, which they do, so we're done. As a last example, let's write the balanced equation for the combustion of nonane, which has the molecular formula C9H20. The first step is to write out the unbalanced equation. Then, because nonane has 9 carbons, we know that there will be 9 CO2s on the right. And as it has 20 hydrogens, we'll have to form 10 H2Os. Then lastly, we just need to balance the oxygens. So there's 9 times 2, or 18, in the carbon dioxides, and 10 in the waters, which is 28 in total. So on the left, we must have 14 O2 molecules, because that totals 28 oxygen atoms. And that's it, our equation now balances. The key point to take away from this video is that the properties of hydrocarbons, like alkanes, depend on the length of their carbon chain, with the shortest hydrocarbons having the lowest boiling points, and so being the most volatile and flammable, which makes them great fuels. And whenever we use a hydrocarbon as a fuel, we call the process combustion, with complete combustion only taking place if there's enough oxygen available. which will produce carbon dioxide and water, releasing loads of energy in the process. Anyway, that's all for this video, so hope you enjoyed it, and we'll see you next time.